There's hardly anything more bizarre in space than black holes. They're invisible and always hungry space phenomena. Some of them come in unimaginably large sizes. In fact, black holes can eat up so much matter that they keep growing nearly infinitely. So how are black holes different from what we imagine? What's the largest one that we've ever discovered? And how much bigger can they grow? To understand how black holes work, you need to understand gravity. To throw a ball to some height, you need to apply a certain amount of force. The same with rockets. Only they weigh a lot more than a ball does. A rocket's speed has to be greater than the gravitational attraction of the Earth. And this speed-to-gravity ratio is known as the escape velocity. The minimum speed needed for a rocket to escape our planet's gravity is at least 11.2 kilometers per second, or about 6.9 miles per second. But what is the escape velocity of a black hole? It's either the same as the speed of light or even greater. And since nothing can move faster than the speed of light, you can't escape a black hole once you're past its event horizon, the boundary of no return surrounding a black hole. But if black holes don't let any visible light out, how can we see them? Although black holes may seem like empty regions of space, they're anything but that. The fact that we can't see a black hole itself, but rather its influence on the surrounding matter, doesn't mean there's nothing inside one. This is due to its strong gravitational field. Anything inside a black hole is tightly packed and cannot get away. As a black hole's gravity attracts gas and matter, it creates a swirling area around it called an accretion disk. And because these different particles around a black hole move extremely fast, they start to heat up and emit X-rays and gamma rays. So, using scientific telescopes and satellites, we can actually detect those rays and assume there's a black hole out there. Another way to spot a black hole is to notice the weird motion of interstellar material and stars that might point to a strong gravitational field beside them. In fact, any object can become a black hole, but you need two major ingredients to make that happen: mass and high density. To make a black hole out of our Sun, you'd have to compress it to a radius of just 3 kilometers. And to make a black hole out of the Earth, you'd need to squish its mass into a sphere the size of a small pea, or less than 9 millimeters in radius. But do such tiny black holes even exist? In theory, there could be one-atom large black holes and even smaller ones. They're usually referred to as quantum black holes or primordial black holes, meaning the smallest of them could be born just after the Big Bang. But if these tiny black holes existed, they would have been harmless, evaporating instantly after their creation, as they'd be much hotter than our Sun. Some scientists speculate that primordial black holes could be one of the components of dark matter. But let's leave hypothetical primordial black holes behind and get down to the type of black holes we've been able to observe. We know that stellar black holes exist for sure, and they're usually formed when a massive star explodes with such power that it shines brighter than an entire galaxy of stars. The phenomenon is called a supernova. Now, similar to how we measure distance in space, which is the distance from Earth to the Sun, scientists use solar mass as a unit to measure the most massive objects in space, including black holes. And the mass of an ordinary stellar black hole is about 3 to 10 solar masses. Cygnus X1 is just an example of a stellar black hole and the first one we've discovered. Cygnus X1 is located in our galaxy roughly 7,000 light-years away from Earth. But what's interesting about it is that it spins nearly at its maximum rate, which is 800 times per second. Even though Cygnus X1 has 21 solar masses, it's still quite a small representative of black holes. Next come intermediate mass black holes, and their name speaks for themselves. For a long time, intermediate mass black holes were a missing gap for understanding black hole evolution, but soon everything might change. This type of black hole is already larger by a lot, as it can have a mass that's hundreds to thousands of times bigger than that of our Sun. In 2006, astronomers stumbled across powerful X-rays, and as you already know, it's one way to detect black holes hiding from our view. These X-rays were tracked to a dense star cluster in another galaxy, and based on the luminosity of the received signal, a black hole is estimated to be about 50,000 solar masses. While scientists still don't know if it's an intermediate mass black hole for sure, lots of signs are there. 50,000 solar masses may look like a big number, but that's almost nothing on a scale of supermassive black holes. One of those, as with most galaxies, sits right in the middle of the Milky Way. Sagittarius A star has a mind-boggling 4.6 million times more mass than the Sun. But it's only 17 times larger. In fact, it's not that big. It could actually sit within Mercury's orbit. Sagittarius A star is still located about 26,000 light-years away from us, so there's no threat to our planet or our solar system. In the meantime, there are supermassive black holes in some distant galaxies that act weird. Spotted and captured by NASA's Hubble telescope, this abnormally bright quasar named 3C186 is in a galaxy that sits 8 billion light-years away from Earth. Now, we already know that the central parts of most galaxies contain a supermassive black hole. But what astronomers found out about this black hole is it's not quite in the middle. In fact, it's located approximately 35,000 light-years away from the center of its galaxy, and that's further than our Sun is from the center of the Milky Way. So what could possibly move a black hole that weighs more than 1 billion suns? Scientists believe that about 1 to 2 billion years ago, there was a collision of two galaxies. As they collided, the central black holes of the two galaxies started to circle each other and eventually merged into one, creating powerful gravitational waves. As a result, a newly formed black hole was harshly kicked out in the direction opposite from the strongest gravitational waves. The power of such a kick was so immense, it could be compared to 100 million supernovae exploding all at once. 3C186 still keeps moving away at the speed of 7.5 million kilometers per hour. At this speed, it could travel from our planet to the Moon in roughly 3 minutes. The new black hole that was born should be much larger than 1 billion suns, but so far we have no idea how massive it could be. To grow that big, black holes need to feed on tons of stars. But don't misinterpret that, they're not space vacuum cleaners. If our Sun was suddenly replaced with a black hole having the exact same mass, there would be no change in the Earth's orbit, and we wouldn't be swallowed up by it, since its radius would be just 3 kilometers, so we'd have to be much closer to it than we currently are. Supermassive black holes are already hard to comprehend, but they're miniature compared to ultramassive black holes. One of the largest and most massive black holes ever discovered in this category would make Sagittarius A star look like a small asteroid placed next to our Sun. Within the huge galaxy Holm 15A, home to roughly 2 trillion solar masses, lies a black hole 40 billion times more massive than our Sun. To compare, it's more than half of the stars in our galaxy put together. Holm 15A sits 700 million light-years away from us, and a black hole in the heart of this galaxy equals the size of our entire solar system. Until recently, scientists believed that the upper limit for the mass of a luminous black hole was about 50 billion solar masses. Little did they know a new discovery would change this. You may not know this, but the brightest objects in the universe aren't stars or galaxies. Quasars are. Not so long ago, a quasar with the brightness of 140 trillion suns named TON 618 was discovered. It's so bright that it outshines the entire galaxy it's located in, and the ultramassive black hole powering it is a real monster at 66 billion solar masses, which makes it even more massive than all the stars combined in the Milky Way. TON 618 has a diameter of 389.8 billion kilometers. The quasar is located in a distant constellation, Canes Venatici, some 10.4 billion light-years from us. Because TON 618 is so far away, its light takes more than 10 billion years to reach us, so we only see how big it was when the universe was just a few billion years old. And by this time, it could have grown a lot bigger. One idea is that for such a monstrous black hole to grow, there should have been a different black hole that served as a seed to feed a bigger one by merging with it. But computer simulations show this isn't what happened with TON 618. A more probable scenario would be multiple black holes merging together into one over time. Still, we don't know if that describes the story of how TON 618 formed, but it remains the most massive black hole we've discovered up to this date. So far, we keep finding new black holes that appear to be larger and larger each time. and scientists have even started suggesting there could be a new class of black holes named stupendously large black holes. These black holes could have a mass above 100 billion solar masses and even a lot more than that. All of this begs the question, if black holes constantly grow, does this mean they're eternal? Well, on a scale of human life, the lifespan of our planet, our sun, and even our solar system, yes. Black holes slowly evaporate and lose a tiny bit of mass through a process called Hawking radiation. But the thing is, it's a very slow process. It'll take about the age of our universe for a black hole with a mass of 100 million tons to only lose 50% of its mass. And the bigger they are, the more this process slows down. Once all the stars fade out or explode, black holes will still be there for a very long time. By the way, if you'd like to see a video about this and how the universe will little by little freeze and die, let us know in the comments. The observable universe is roughly 46 billion light years in radius, so there's a lot more out there to surprise us. One day, we'll hopefully find something that could shed light on the dark, mysterious patches scattered out there in the skies. So far, it's like trying to guess what's behind a door, while only knowing what size the room could be and its temperature. We hope you enjoyed this video, and thanks for watching.